So we learned, guys, why it was important to know about rotations and reflections and translations. So we also needed to talk about symmetry. If you look here, we have a shape, a letter A, and this letter A has one line of symmetry, exactly one. And the reason for that, it's called a line of symmetry because if I was to cut this in half or fold it in half, this side would fold over and it would fit exactly over the other side. So that line that's right in half is called our line of symmetry. So this A would have only one line of symmetry. You could think of a letter B, for example, and ask yourself, how many lines of symmetry would that have? Well, I can only think of one way to chop this up so that it would fit one on top of the other. So this would also have one line of symmetry. Let's look at the second part. This one says they want us to graph this. So it says to reflect it, and we're going to reflect it over first the x-axis. Okay, so let's go ahead and do that. The first step is to graph 3, -4. So remember, this tells me to first go +3. So that, remember, positive number in the x tells me to go right. So I'm going to go ahead and I'm going to go +3, so I'm right here. And then this y tells me to go 4 down because it's negative, so I go 4 down. And here is my point K. Now I'm going to reflect it. When we reflect, remember, it's like if you were standing in front of a mirror, your image is going to be reflected and it's going to be the same distance. If you could measure yourself, your distance to a mirror, and then from the mirror to your reflection, that distance is basically the same. So the same thing's happening here. We have K. It's going to be a certain distance from the line that we're reflecting it, which is the x-axis. So for the first part, here's my x-axis. I'm going to count how far away it is. It's 1, 2, 3, 4. So if I wanted to reflect it across that, I'm going to count the same amount of spaces. 1, 2, 3, 4. So here is my new shape. And if you notice, it's written with this little arrow. Apostrophe. That little apostrophe is there to help to remind you that this is the reflected point, not the original point. Let's go ahead and try the over the y-axis. Okay, well, here's my y-axis. So we want to see how far away it is. K is 1, 2, 3 away from this line. So since it's 3, I'm going to count 3, but on the opposite side of my reflection. So 1, 2, 3. Here is my new K. And again, we write it within a little apostrophe to show that it's the new one. Okay, so now we're going to go ahead and look at example 3. In example 3, we have 3 coordinates, and we want it to reflect it over the x-axis. Okay, so we would first start by graphing these coordinates, and then we're going to do a reflection. So I'm going to go ahead and graph A. A is at -3, 1, so I move 1, 2, 3, and 1 up. There's my A. To graph B, it's -1, so I'm going to go 1 to the left and 4 up. 1, 2, 3, 4. There's my 4. And then I'm going to go 2 to the right since it's +2. So I go 1, 2, and 1 up since it's positive. There are my points. Okay, now they want me to reflect it over the x-axis. Well, here's my x-axis. It's right here. So we need to count all of those points. How far away from that line are they? And then count the same amount of spaces, but on the opposite side. So for example, A is 1 away, so I'm going to count 1 away, and there's my new point. C is 1 away from this line, so I count 1 away, and I make my new point here. B is 1, 2, 3, 4 away, so I'm going to count 4 on the opposite side down. 1, 2, 3, 4. And there are my new points. And then they ask us to give the coordinates. That would be down here. The new coordinates are the following. Okay, and we can check that Okay, A is at -3, -1, yes. B is at -1, 1, 2, 3, 4, -4. And C is at -2 and then -1. I mean, sorry, +2 and then -1.